Okay, this is section 1.3, and we're going to talk about solving equations in this section. This is basically just your basic kind of linear equations that you saw in Algebra 1, but as we've been talking about throughout this chapter, this is a big review of Algebra 1 in this chapter, so we want to make sure we have some of these concepts of solving equations down solid, so when we get into some more harder types of equations in the actual Algebra 2 part of the course, we can be very successful. Okay, so the first thing I want to talk about actually isn't solving equations, but writing equations and expressions when you're given what are known as verbal expressions, so when you're given words. Okay, so if you take a look here, I have two definitions right here on this slide about what a verbal expression is versus what an algebraic expression is. So verbal expressions, like you would expect, contain words, and algebraic expressions contain algebra. Now the trick is being able to go from one to the other, particularly when we see this a lot when we deal with word problems. When we want to try to write a word problem into an equation or an expression that's going to enable us to do the algebra on it. I think that's where a lot of students have hang-ups when they deal with word problems. So I want to start early with this and go from how to turn words into expressions. So that way when we get into word problems later on in this chapter and beyond, we can be much more successful. Okay, so I have three examples here. These are the same three examples that are in your note sheet as well. We're going to go through these together and just give you some ideas of things. Now the key when I write an expression is I read it from left to right, the same way I read words in a book. And the part that always hangs up students is there's certain key words and key expressions that mean something mathematically. Okay, so we'll start with the first one. 2 more than 3 times a number. All right, so all the numbers I know are going to be the numbers. So we have a 2. So I'll write that first. More than. Okay. When I see more than, I always think plus. So that's got to be a plus sign. Next. 3 times a number. All right. Well, times is multiplication. A number, I don't know what the number is. I'm going to call that a variable x. So 3 times a number would be 3 times x. And remember now in algebra, we don't write times because we have the letter x. We don't want to confuse a times symbol with the letter x, so we just do 3x. So these words become 2 plus 3x. Okay, so if we take a look at the second one now, we have the quotient of 5 less than a number and 12. All right, so quotient always means divide. So I'm going to put a big old division line here to tell me we're going to be doing some dividing. What are we going to be dividing? This first expression here that I put in parentheses, 5 less than a number. Okay, less than is a tricky phrase. Less than means subtraction. But the thing that's tricky about less than, and you need to pay attention to, is we technically don't write this from left to right the way we see this expression. So this won't be 5 minus a number. It's actually a number minus 5. And since I don't know what the number is, I'm going to just call it x. So 5 less than a number is x minus 5. And then the other number we're dividing is 12. So the second expression becomes x minus 5 all over 12. Okay, the third example, the sum of 3 times a number and 16 is 97. Okay, so sum is addition, so we're going to add 2 numbers. The 2 numbers we're adding is this 3 times a number thing and 16. 3 times a number, 3 times x, a number, and 16. So the other number we're going to add is 16. So 3 times a number and 16 sums to the expression 3x plus 16. Is. Keyword. I'm actually going to box it. You're going to see it a lot, especially in word problems. Is means equals. So this sum is equal to 97. Okay? You have a couple examples to practice on your note sheet. Pause the video, give them a try, and then when you pick up where you leave off on this video, I'm going to show you how to do them. Okay, so let's take a look at the first one. 7 less than a number. So this is a subtraction because of the less than. Remember we talked about in the last slide, this is a little bit of a red herring, this phrase less than. We have to actually reverse the order. So we'll start with a number. We don't know what that is, so we'll just call it x. Less than means subtraction, and then the number that we're given is 7. So 7 less than a number can be rewritten as x minus 7. If we look at the next one, the square of a number. Okay, so we didn't really talk about the square of a number, but that just means x squared. Decreased by. Decreased, same thing as subtraction again, just like increased would be addition. The product of 5 and a number. 5 and a number. Product is multiplication, so we do 5 times x. The last one, 7 times a number minus 2 is 17. This is nice. We can go right from left to right. 7 times, so multiplication, a number minus 2 is, there's that is again, is equals 17. So 7x minus 2 equals 17 is the equation that corresponds to that statement. Now that we have equations, let's start to solve them. Okay, so I have a couple examples here. I'll do them with you. Remember, the first thing we always want to do is we want to get variables equal to a number, always. So I've got variables on both sides of this equation. I've got a 2x over here on the left, and I've got a 4x over here on the right. So I'm going to bring them to one side. It really doesn't matter which side you bring them to. I'm going to add 4x to both sides because, to me, I like to keep the x positive, and if I were to subtract 2x over to the right, that would give me a negative. Now that I have x's on the left, I got to bring the numbers to the right. So since I have minus 3 on the left, to get it to the right, I have to add 3. So I get 6x equals 12, divide both sides by 6, x is 2. All right, and remember, if I want to, I can plug in 2 for both of these x's and check to see if it worked. All right, next equation, same idea. We have 8x plus 12 on the left equals 5x minus 21 on the right. So why don't we get x's to both sides? So first step would be to subtract 5x from both sides. Now I have x's on the left, so I need to get the numbers on the right. And my last step then is to divide both sides by 3, and negative 36 divided by 3 is negative 12. Okay, and that's my answer. And again, I could check it by making both x's negative 12 and making sure that the expression on the left gives me the same value as the expression on the right. Let's look at a few more. Okay, we've got some parentheses here. We've got a lot of x's all over the place. So first thing we want to do is, like order of operations said in the first section, I want to get rid of these parentheses. And the way I do that is I got to use the distributive property. So on the left-hand side, I'm going to take this negative 7, and I'm going to multiply it into my parentheses. So I get 3x minus 14x plus 91 equals negative 6x plus 27. Okay? Next step I'm going to do is I'm going to combine my like terms. See this 3x and this negative 14x? I want to make it just one term with an x. So negative 11x plus 91 equals negative 6x plus 27. Okay, I've got x's on both sides. I need it to be just on one side. But I add 11x to both sides. That lets me undo the left, so I have 91. And then I have negative 6 plus 11 is positive 5x plus 27. Subtract 27 now. And I get negative 65 equals 5x. Divide both sides by 5. And x is going to be negative 13. Okay, and again, we can always check that work. Let's look at one more like this, a little bit more complicated. This is really as hard as it's going to get as far as multi-step equations in this section. All right, so again, I've got two sets of parentheses on the left-hand side. I want to get rid of them. So I want to use my distributive property first and bring my outside numbers in. So I've got 4x minus 2 minus 12x minus 4 equals 2. Be careful with this second set here, ladies. When you distribute, you're not just distributing a 4, distribute that minus 4 in, so that way you're not going to get confused with double negatives. So I really did negative 4 times positive 3 gets me negative 12, and negative 4 times positive 1 gets me negative 4. Okay? Now I've got two terms with x's, so why don't I combine those? 4 and negative 12 makes negative 8. I have two numbers on the left side as well, so I'll combine those, and I get negative 6. All right, I already have just one x term, so I'm going to move all the numbers away from the left-hand side, so I'll add 6 to both sides. Divide both sides by negative 8. X is negative 1. Okay? With that, you have some practice problems I want you to give a try, and we'll go over those answers in class, and we'll look at some other things with solving equations in class as well. So with that, I wish you a good evening.